Hello, I'm going to talk about the copy function, from the algorithm library. So it's really simple in terms of the behavior. It's pretty much just assigning element one by one, and it assumes that your destination, has enough space to hold everything. If not, you segfault. But let's look at my code here. All right. So I have two questions. One is the implementation of the various compilers really that simple? Visual Studio, GCC, is it really as simple as what the website shows, right? And why should I bother using this function? I mean, you could just loop through manually, right? Well, if you loop through manually, it's pretty much the same as the implementation here, right? Because that's what it does. But or you could just call main copy. If you don't require deep copy, you can just call main copy. So why should you use this? So let me try to answer these two questions using my demo code here. All right, so just a bunch of boilerplate stuff. So right here, I just copy and pasted. I just rename it my copy, but this is just what's on the website. And I made a class called foo. All foo really is just a iterator that prints out what it's being called. So if constructor is being called, then it's printed out. Then okay, and then if copy constructor is being called, then it prints it out. And if various operators are being called, then you also print them out. And finally, destructor will get printed out when that's being called. So I'm going to use my foo object as a tool to look inside as to what copy. So my copy, I kind of know. Well, I know exactly how foo will behave if I put it as the result input. But I can use it to compare to the standard template library's copy function. So that's what I would do. And I also have a timer class to test the timing. The naive my copy function versus STL's copy function. Right. So here, here, hold on. Here, let me first demonstrate. So right here, I create a foo object. So foo object, if copy and my copy implementations are exactly the same, then they should print the same thing because it's the same v1 that's being copied into f iterator. So compile this. Hold on. It's here. All right, compile this. Let me compile without any optimization flag. So this is just the default setting. All right. So as you can see, it 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 calls the copy function calls a lot. I mean, it passes. It seems like it passes the full object by value quite a few times, and my copy function just behaves how I expect it to behave because I wrote the thing. So you might wonder, why did it do that, right? And is it actually gonna be slower than if you write a loop by yourself? Then it says no, it's gonna be a lot faster actually, unless you only copy one or two elements all the time. But that's not what copy it's used for. So you want to copy a lot of things. So that's why I have a stopwatch class to measure things. So let me explain what's going on here. I have a v2 vector. So I made it like 4 vectors with a million elements each, and each element is equal to 0. And for v2, I'm setting every element to be random, just kind of like a random number between 0 and 100. Uniform distribution. I did that because I want to make sure it's kind of reflecting real world usage. Otherwise, I don't know what the compiler would do if I just have some kind of pattern there, or copy ones, copy O1s or something. That's too easy. So I have a stopwatch here. Line 120, my stopwatch object. I started my stopwatch, and I do my copy using the default. I stop it, and I repeat the same process 3 times using 3 different methods. The first one is the default copy. The second one is my copy. The third one is main copy. And here's the result. All right. You can see that both copy and main copy are significantly faster than my naive implementation. So that implies when you want to copy something, a container to another container, you never want to write a loop by yourself. Never ever. You want to use copy, okay? If it's a C array, you could use mem copy, but if you look at the time, it's pretty much the same. You are pretty much, splitting hair here. And if you really care about the time that much, like this tiny bit of time differences, I think you'll be better off trying to optimize somewhere else, or try not to copy, or I don't know, don't use C++. But that's my conclusion is pretty much copy and main copy at the same time, and the loop is significantly slower. One last thing is, let me just, to make sure, hold on. Let me just compile with optimization turned on and see, just to make sure. So pretty much the same still. All right. My copy is a lot slower than the other two. And let me try to use different compiler. So this was Visual Studio. So if I use another compiler, so if I copy everything, let me copy everything over. So right here is I think it's a free BSD machine. All right, let me just. All right. So wait, CPU info. Anyway, it's all right. I'm gonna use G++. Copy dot. Oh shoot! What is going on here? What is going on here? Oh. I didn't copy it correctly. Oh. Include. All right, so you can see it's still the same. The results about the same as Visual Studio. Hold on. Huh. All right, so you know. Yeah, O3 is interesting. Turned out that my copy for O3 is optimized pretty good. Well, I should not say optimized pretty good. I mean, I should say all of them are optimized pretty bad because they are worse than O1. But there is never the case that copy is slower than my copy. My copy is always the slowest. So just don't ever read your own. Try to use copy whenever you can. It's more readable. It's more flexible because it performs deep copy. If your objects inside has that functionality. But main copy obviously does not do any of that. So, plus you can copy in reverse order. You can copy things to, you can use what's that called? Iterator adapters. So you can copy it to the terminal. Oh, you can copy it to OStream. So, not just containers, but other things using iterator adapters. So it's really flexible. So that's it.